First up, an algebraic expression consists of one or more numbers and variables along with one or more arithmetic operations. Could be 5x, 3x minus 7. Could just be a number, 25. We use these words for addition, subtraction, multiplication, and division. Make sure you especially know words like product and quotient as we translate words into expressions. I find it helpful to plug in a sample number. So if we're spending $1,500, and let's say we bought 10 calculators, if you wanted to find out how much they cost, you would divide by 10 to figure out they were $150 each. We don't actually have to solve anything here. We just have to identify the operation. So based on my test, division is the operation, and the answer is 1,500 divided by C. This will work for any number of calculators. I see the word quotient, which means division, so I write my answer as 4 divided by n. If they cost $16 each, let's say I bought 10 games, that would be 16 times 10, $160. That's my test case, right? We don't actually need to know that. We just need to recognize that it's multiplication. So we're going to put n for the variable, and the answer is 16n. Sum means addition. Square of x is a fancy way of saying x squared. So I'm going to take x squared plus 5. I started with some number of employees. It decreased by 22, and now I have 85. Let's put in an x for that original population, and this is now a one-step equation. If I add 22 to both sides, I originally had 107 employees. Product means multiplication, and sum means addition. So I'm going to write 8 plus n. Second part to this one, evaluate if n equals 3. So I'm going to substitute. This is now 3 times 8 plus 3, or 3 times 11, which is 33. I'm going to match up the 300 for hamburgers with the x, 300x, and I'm going to match up the 250 with the y. That's the number of calories per hamburger and the number of calories per bag of fries. Now here they tell us to plug in 2 for hamburger and 1 for fries. So this becomes 300 times 2 plus 250 times 1. This gives me 850 total calories. This one they give me the expression 5w plus 2p, and then they tell me to plug in 2 for w and 3 for p. So that's 5 times 2 plus 2 times 3. Or 10 plus 6, which is 16. Next up, for combining like terms, it helps to know some vocabulary words. X here is my variable. Y is also a variable. If they're different letters, you can't add them together. 5 is the number in front of x, same way that 2 is the number in front of y. Those are called coefficients. If there's a number all by itself, that is called a constant. Another feature we have to watch out for is exponents. These are the superscript numbers, like a 2, up in the top right. The items underlined in red are all number terms or constant terms, so I can just combine them. 8 plus 2 is 10, 1/2 plus 1/2 is 1, and then minus 1. So 10 plus x. A convention of math is that we tend to write the letter first. We don't solve anything, we just simplify where we can by combining like terms. Next up, the x terms can be combined. We don't change the variable, we only look at the coefficients. 4 plus 2 is 6x. Though every term has a p, these two can be combined for 7p plus 2p squared. When there's a different exponent, they cannot be combined. That convention of math is that we write the highest exponent first. So this would be the correct way to write this. Sometimes we have to distribute before we can combine like terms. So this would be 12n minus 12 plus 2n. And then we can notice that the n terms can be combined. So this would give us 14n minus 12. Bit of a trick question here. There's an x squared, a constant, and an x. These are all three different terms. So there's nothing we can do. If you wanted to, you could rewrite it in this order, but that's it. C to the power of 6 is one term. I combine the coefficients, 9 minus 7, 2c to the power of 6. Notice that the exponent does not change. It's used like a unit. So this is like 9 apples, take away 7, how many are left? Next up, I can combine the c terms. This gives me plus 7c. And finally, I have just 2. The square root of 25 can be simplified to 5, and it's a number, so we can add that number to the negative 25 and the positive 3. When we combine 5, negative 25, and 3, we get negative 17 plus x. And we can rewrite that as x minus 17. 4 squared can be rewritten as 16. I have my constants, 16 and 7. And my x terms, 3 and negative 7. Pay close attention to those negatives, because this will pull it into negative 4x plus 23. I don't think you'll see any of these on the quiz necessarily, but when we have xy, that is a unique variable. It's different than x or y. In the same way that a different exponent makes it unique, a different combination of letters will also make it unique. But we can combine them. 3xy plus 5xy is 8xy. Here I'm looking for x cubed terms. There's only one. And then if I look at the x squared terms, plus 3 and minus 3 actually cancel each other out, because 3 minus 3 is 0. And finally, I have the y squared terms. Those can be combined. So 3x to the power of 3 plus 10y squared. For one-step equations, we have to remember the opposite operations. If we want to undo multiplication, we do that with division. If we want to undo addition, we do that with subtraction. If we want to undo a square, we do that with the square root. Notice that if there's ever a radical that does not have a number, by default, there's actually a 2 there. And if we want to undo a cube, we can do that with a cube root, and vice versa. So I start on the side with the variable, x, and I see what's there, minus 7. So I do the opposite, plus 7. And this gives me x equals 32. I start on the side with the variable, whatever's there, I do the opposite operation. Since it's plus, I do minus, and this gives me 17.1. When the number's just to the left of the letter, that implies multiplication, and you always divide by whatever is in front of the variable. So here, negative 8 over negative 8 cancels out, and we have m is equal to negative 6. When there's a fraction like h over 7, that means division. So we cancel out with the opposite operation, which is multiplication. So that gives me 42 is equal to h. When there's a fraction in front of x, that's like multiplying by 3 and dividing by 8. You can do this by multiplying by 8 first, which cancels out the 8. And then you have 3x is equal to 24. And then you can divide by 3 and get x is equal to 8. The reason why this shows up in the one-step equations is because you can also multiply by the reciprocal of the fraction in front of the variable. So I look in front of the variable, there's 3/8, and I can multiply both sides by 8/3, which goes away. And this tells me that x is equal to 3 times 8 divided by 3, which is just 8. Whether you do it in 2 steps or jump straight to the reciprocal, they both give you the same answer. When there's a fraction in front of x, 1/3, I can multiply by 3. What that does is it cancels out 3 over 3. So I'm left with 9 over 9 is equal to x, or in other words, 1 is equal to x. If you wanted to cross multiply in this one, you would just bring the 1 up here, and you would do 3 times 3 is 9, 9 times x is 9x, and you're going to get the same answer. To cancel out a square, you take the square root of both sides. Now technically it's plus or minus 7, but we're just sticking with the positives for now. When there's a cube root, you cancel that out by taking things to the third power. So x is equal to 3 times 3 times 3, which is 27. When you have an x on the bottom, you still multiply by whatever's on the bottom. So I'm going to multiply both sides by x. This cancels out, and now I have 12 is equal to 4x. I divide by 4, and the answer is 3. Another shortcut that can be confusing but works out if you remember how to use it is that you can switch these two, and you get 12 over 4 is equal to x. Same answer in one step. Some students just like to think about 12 divided by what gives me 4. And with small numbers like this, you can possibly just puzzle it out. This is a great candidate for cross multiplication. When you have two fractions set equal to each other, you can do 12 times 12 is equal to 9 times x. Doesn't really matter the order. Any way you do it, you'll end up with 144 is equal to 9x. When you divide by 9, you get 16 is equal to x. When we start solving two-step equations, you have to follow the order of operations in reverse. So we start down here at the bottom, and the first thing that we are going to cancel out is any addition or subtraction. The next thing we do is we cancel out any multiplication or division. Then we look at exponents and finally stuff in the parentheses. That's how we know to subtract 5 from both sides first, and then divide by 2, because we follow the order of operations in the reverse order. If you wanted to test your answer, you could say 2 times 12 plus 5. Does that equal to 29? Yes, it does. Plus 14 to both sides first, following the reverse of the order of operations. Then you divide by whatever's in front of the variable. Negative 5 is equal to d. A lot of students like to distribute. You could do that. 2z plus 2 is equal to 16. You would then deal with the addition first. 2z is equal to 14. When you divide by 2, you get that z is equal to 7. It's also possible to deal with, think of it as multiplication in parentheses, which means you divide by 2 first, and you get that z plus 1 is equal to 8. And then you minus 1, and you get that z is equal to 7. Both of these work. First we cancel out the subtraction, and we get d over 3 is equal to negative 3, because we started negative and we're heading towards 0. Remember, the fraction bar is like division, so we're going to multiply both sides by 3. That cancels things out over here. We get d is equal to negative 9. Following the order of operations in reverse, first we deal with the subtraction. Be careful that you are using the equal sign as a divider and that you add once on each side. Otherwise, you're going to disrupt your scale and it will no longer be equal. So here we have 3q is equal to 12.9. Then we divide by 3, and we get that q is equal to 4.3. They asked as a bonus to find q plus 3. Sometimes the SAT asks questions like this. So if you plug in 4.3, the answer is going to be 7.3. First thing I do is subtract 1.3 from both sides. This gives me a negative 4.7 is equal to a negative 2t. Then I divide by negative 2 on both sides. I get a positive 2.35. First I deal with the addition by subtracting. I have x squared is equal to 16. Then I take the square root of both sides, and this tells me that x is equal to 4, because 4 times 4 is 16. First I subtract 7 from both sides, so I have 2 is equal to the square root of x. Then I square both sides to get rid of the square root. This tells me that 4 is equal to x. When we get into multi-step equations, we're going to add these 3 steps at the beginning. And after that, everything will end up being the same. So the first thing we're going to do is we're going to distribute anytime we see a number outside of parentheses. Then we're going to combine like terms. A key idea is that they have to be on the same side of the equal sign to do so. And finally, we're going to move the variable to one side. So if we see x's on both sides, we have to address that first. There's nothing to distribute, no combine like terms to do. I'm going to subtract a from both sides. I'm left with 6 is equal to 2a minus 8, and now I'm at a two-step equation. Just like before, I can add 8 to both sides, and then I can divide by 2. And I get 7 is equal to a. First thing I'll do here is distribute. 6z plus 18 minus 9 is equal to 27. The next thing I can do is look for constants that are both on the same side. 18 and minus 9. I can rewrite that as plus 9. And now it's business as usual. It's a two-step equation. I subtract first, and I get that 6z is equal to 18. I divide by 6, and I get that z is equal to 3. When we have fractions across multiple numbers, sometimes it helps to think of a common multiple. I'm going to choose 4. I'm going to multiply everything by 4. So this is kind of like 4 times 3 divided by 4. 4 times 3 is 12, divided by 4 is 3d. 4 times 1 divided by 2 is 2, and 7 times 4 is 28. Now I can proceed like normal. It's a two-step equation. I'm going to add 2 to both sides. I get 3d is equal to 30. When I divide by 3, I get that d is equal to 10. Sometimes multiplying by the right number can make a problem a lot easier. Because I have two fractions that are equal here, I'm going to rewrite this as 4 over s is equal to negative 2 over 9, and I'm going to cross multiply. 4 times 9 is 36. S times negative 2 is negative 2s. Then I'll divide by the negative 2, and I get negative 18 is equal to s. Here I have to combine like terms. 3x and minus x, they're on the same side. That'll give me 2x. Plus 7 and minus 9 are on the same side. That'll give me minus 2 equals 6. Down to a two-step equation. I deal with the subtraction first. 2x is equal to 8. Then I look at some division to cancel out the multiplication. X is equal to 4. There's an x on both sides, so I'm going to keep things positive by subtracting 2 instead of 4. This goes away, and I have 7 is equal to 2x minus 9. Now I'm looking at a two-step equation. I'll deal with the subtraction first. I have 16 is equal to 2x. I'll divide by 2. 8 is equal to x. For this last one, there's a couple different ways. You could subtract x over 2 from both sides. If you remember that fractions can be subtracted if they have the same denominator, this gives me negative 7 is equal to 2x over 2 minus 9. Those 2's cancel out, and I can just add 9 to both sides, and I get 2 is equal to x. If I wanted to instead, I could try multiplying things by 2 to get rid of the fractions. For example, 2 here, 2 here, 2 here, and a 2 here, every single term. This can be rewritten as x minus 14 is equal to 3x minus 18. I might subtract the x from both sides. Negative 14 is equal to 2x minus 18. If I add 18 to both sides, I get 4 is equal to 2x. And once I divide by 2, 2 is equal to x. In this case, I don't think multiplying really helped me. But both work. For this last one, the first thing I do is distribute. When there's a negative there, that's like distributing a negative 1. So I have 2x plus 2 minus x minus 1 is equal to negative 17. I'm going to combine the x terms on the left. That gives me x. I'll combine the number terms on the left. That gives me plus 1. I can subtract 1 from both sides, and I have x is equal to negative 18.